And the first one here, we have a square root of 25a to the fourth b to the ninth. So we can break that 25 into 5 squared. We can break the a into a to squared. Now b is to the ninth, right? We're doing a square root, so we still can simplify that a little bit and get rid of some of them out of the radical and leave one behind. So b to the ninth is the same thing as b to the fourth squared times an additional b. That one b on the outside is going to be left inside because now we can get rid of all of these squares and move all three of these out. So then we now have our final answer of 5a squared b to the fourth times the square root of b. And there's our simplified answer. Same process for the next one, but now we have a cube root, and 125 is the same thing as 5 cubed. So conveniently, we can change 125 to 5 cubed. M to the 30th is m to the 10th cubed. And we're going to do the same thing to p here that we did to b earlier. P to the 6th cubed. So 6 times 3 is 18, which means we still have 2 p's left over. So p squared will remain inside of our cube root. I forgot the cube in the front. So now our final answer, cube root, not cube root anymore. Now it's 5 m to the 10th, because we'll get rid of all these cubes. P to the 6th times the cube root of p squared. So there's our answers for this one. Moving on. So here we have the square root of y to the 8th and x to the 7th. We can again split those into the square root of y to the 8th over the square root of x to the 7th. And we're going to break these down like we did previously. So we have y to the 8th is the same thing as y to the 4th squared. And x to the 7th, since it's odd, we're going to have to break off one x by itself. And then have times x to the, since we took one away, we have 6. 6 divided by 2 is 3, so x cubed squared. So now we can get rid of these squares, move these specific things out of the radicals, and we will have y to the 4th over x cubed times square root of x. Now we can't have a radical on the bottom of a fraction. That's not simplified. So we need to multiply this by just the square root of x over square root of x. I don't want to put an equal sign there, just a times sign here. So we multiply across, and we get y to the 4th times the square root of x over the square root of x's will cancel the square roots. We'll be left with 1x. So it's x cubed times x, which simplifies one more time. So we have y to the 4th times x squared over x to the 4th. The second one, both of these have issues here. We can still go ahead and break them apart. So it's the cube root of 2 over the cube root of 9x. Neither one of these simplifies, but we do need to get rid of that cube root on the bottom. Again, no radicals on the bottom. So we're going to multiply by something that will get rid of that cube root. It's called the conjugate. So 9 we know is 3 squared, right? So if we multiply it by one more 3, then we'll be able to get rid of the 9 in the radical. So we're going to multiply by a cube root on both of these, top and bottom, of at least 3. And we know that x is just x, so to get rid of that x in the radical, we need to multiply it by x squared, because we want it to be an x cubed. So when we multiply both of these by, or top and bottom, by the cube root of 3x squared, that will make it a cube root of 6x squared on the top, which is fine. We can leave that just like it is, and we don't have to simplify it any further. And the bottom will become the cube root of 9 times 3 is 27. X times x squared is x cubed. So 27 again is 3 cubed. I had to pause for an announcement there. But 27 is the cube root, or is 3 cubed, so we can simplify that and get it out of the radical. And same for x cubed, so we just have 3x on the bottom, and that is our solution. Simplified form. Moving on. So now we got some more to simplify. Now we're going the other way. We have some that are multiplied together outside of a radical, but we do have radicals involved. So what we can do here, since we do have both cube roots, we can multiply the stuff inside together. So we have this 5 outside of a cube root. 100 times 10 is 1,000. A squared times a is a cubed. So we can break these down because 1,000 is just 10 cubed, and a is being cubed as it is. So now we can actually get rid of the cubes here and the cube root. So we now have just 5 times 10a, and 5 times 10 is 50, so this is 50a. No more radical at all on that one. The next one, same concept. We can multiply these together, and we can multiply the numbers outside together as well. So 2 times 3 is 6, times the cube root of 4 times 16 is 64, and a squared times a is a to the third, so a cubed. So now, again, we have the same advantage we had before. 64 happens to be 4 cubed, so this is 6 times the cube root of 4 cubed times a cubed, and again, cubes and cube roots can cancel. So now we have 6 times 4a, and 6 times 4 is 24, so this is 24a. Moving on, we have some addition ones to look at, actually just one. So now this one is probably the longest problem on here, but it's just a lot going on with it. So we have all these radicals, we want to break them apart. So 3 times the square root of 45, 80, and 20 all are multiples of 5, right? 5 goes into all of them. So that means we can break out a 5 for each of them. 45 is 5 times 9. 80 is 5 times 16. And 20, is 5 times 4. So conveniently, all of these things that 5 is being multiplied by are perfect squares. So we have 3 times the square root of 5 times 3 squared minus 5 times the square root of 5 times 4 squared plus 4 times the square root of 5 times 2 squared. So that means that we can take each one of these, get rid of our squares, and move them out and multiply them by the number out front. So 3 times 3 is 9, square root 5. 4 times 5 is 20, square root 5. And 2 times 4 is 8, square root 5. Since all of these have the square root of 5 being the same with all of them, we can actually add these all together. So 9 minus 20 is 11, and negative 11. Negative 11 plus 8 is negative 3. So this is negative 3, square root of 5, answer. Got 2 more problems to get through. So next one is a couple of binomials with radicals being multiplied together, and we are just going to multiply them like we would any type of binomials like this, foiling. So we multiply 2 square root 3 times 3 and 2 square root 3 times negative square root 3. 5 square root 5 times 3 square root 5 times 3 and 3 square root 5 times square root 3. So now 2 square root 3 times 3. We just multiply the 3 and the 2. That gets us 6 square root 3. The next one is negative, because it's a positive times a negative. 2 times the square root, or 2 square root 3 times square root 3 gets rid of the square root, and now it's just 2 times 3, which is 6. And then 3 square root 5 times 3 is 9 square root 5. And square root, or 3 square root 5 times square root 3, we multiply the numbers inside again, so 5 times 3 is 15. That's not a perfect square, so it's just 3 square root 15. We have no like terms here, so that is our final answer. We could break apart the 15 if we wanted to, but really we can't, because 15 is just 3 times 5, and that's the only breaking apart we can do with that. We can't pull anything out, so there it is. And our final problem is a word problem. We want to use the conjugate to rationalize the denominator and simplify the expression here for the formula we have. So all we have to do is multiply a over a square root 2 minus a by the conjugate over itself. So conjugate of the numerator is a square root 2 plus a. And we multiply that times 1, right? Because it's the same thing on top of itself. So when we do that, we got to multiply a times a square root 2, which is a squared square root 2. A times a is a squared. And the bottom we have to FOIL. So we have a square root 2 times a square root 2. So that's a squared. Square root 2 times square root 2 is just 2. So times 2, or just 2a squared. And then we have an a square root 2 times a, so that is a squared square root 2. Now we have a negative a times a square root 2, so that's a negative a squared square root 2. And then we have negative a times a gets us a negative a squared. So now the middle two are opposites of each other, so they cancel, which means we don't have any radicals, which is why we multiply by the conjugate. And then we need to do a squared. You can factor out an a squared on the numerator. So we have square root 2 plus 1 on the top. And on the bottom, we have an a squared in both of these as well, so we can factor that out. And we have 2 minus 1. So that means we can go ahead and cancel out the a squares. So we don't have any a's anymore. So now the top is just square root 2 plus 1. And the bottom 2 minus 1 is 1. So we don't have a denominator anymore either. And that is our solution, square root 2 plus 1.